expanding algebraic expressions. We have a number of different laws and rules that we can use to expand algebraic expressions. So what that means is we're basically trying to get rid of any brackets involved in some type of expression. So please copy these into your exercise book. We'll start off with the distributive law. So if I have A multiplied by B plus C, then to remove these brackets, what I need to do is I need to first multiply A by the first term, then I multiply A by the second term. So A times B is AB plus A times C, which is AC. If I had a subtraction here, this here would be minus AC. Next, if I have a binomial product and I'm subtracting A plus B times C plus D, I'm going to use FOIL, which is a process that you would have learned in year 9. So I'll just review the process. We start off with our first term A, and we go A times C. Then we have plus. Now this A term again, we're going to multiply it by D. So we've multiplied our A term by each of those. Then we're going to move to our B term. So plus. And this B term is once again going to be multiplied by each of these terms. So B times C is BC plus B times D is BD. The difference of two squares is a special scenario where we see that we have the same term A and B in each of our factors. However, this factor has a plus, whereas this one has a minus. When you see something like this pop up, we can use a special rule. To remove these brackets and to expand these brackets, what you'll see is that this will become, you look at your first term, and it's going to be A squared minus B squared. And finally, if I have an expansion of a perfect square, so if I see something that looks like A plus B raised to the power of 2, what we need to do, we take our first term, A, and we square it. So we have A squared plus, now the next bit is the part that some people forget at times. We have 2, it's always 2, times A times B. So it's going to be 2AB plus, and then finally, B squared. And the final scenario, if I have A minus B all squared, it's going to be similar but slightly different because of this minus. I take my first term, it's going to be A squared. Now it's going to be minus 2AB, so it's always 2 times this. And then finally, plus B squared. So please copy each of those rules into your exercise books and use them as you work through the following examples. 7 times m plus 5. So remember, what I'm going to be doing is I'll be multiplying my outer term by each of the terms within the bracket. So it's going to be 7 times m plus 7 times 5, which is 35. Next, I have 3x times x minus 4. So I need to multiply this outer term by each of the inner terms. So first it's going to be 3x times x, which is 3x squared. Then it's going to be 3x times negative 4. So it's going to be minus 12x. And then finally, I have minus a times everything that's within this bracket. So it's going to be minus a times 2b, which is minus 2ab, and then minus a times 9a, which is minus 9a squared. Okay, you might want to pause the video now and have a go at the questions which I've set on sector which are related to those, or you might want to continue watching me go through the other examples and copy all the examples into your book, then move on to working through the questions which have been set on sector. So next, we're going to be multiplying again our outer term x squared by x cubed. This is where we're going to have to use an index law. So remember, when we're doing a multiplication like this, we're adding the indices. So I'm going to need to get x to the power of 5 plus x squared times 6 is 6x squared. So that is equal to that. And then with b, we have this term here. So I won't rewrite it, I'll just do it below it. We're going to multiply this term by this. So we're going to be able to multiply the constants, and then the k terms, because they have the same base, we'll be able to add their indices, and then because it's all multiplication, the m term will also appear in our result. So let's start off with our constants. We have 5 times 3, which is 15. Then I have k to the power of 3 times k to the power of 5. So we add those indices, which gives me k to the power of 8. Then it's going to be m to the power of 4 times the thing, which is still going to remain as m to the power of 4. Now we have to multiply this by the second term. Since this is a minus, it's going to be subtract. So again, let's multiply the constants first. 5 times the 2 is 10. And this time I don't have anything to multiply the k with, so that's going to remain as is, k to the power of 3. And then m to the power of 4 times m to the power of 2. Remember, we add the indices, so it's going to be m to the power of 6. Okay, again, on sector, there's some questions which relate to these, so you might want to have a go at those before moving on to the next example. So now you can see that we have 2 sets of brackets. So this is where we're going to be using FOIL, or this is where we're expanding binomial products. So remember, when I'm working through a question like this, I need to first multiply this m term by each of these terms, and then I move on to multiplying the 5 by each of the terms, and then if there's any like terms that I can collect, I'll do so. So m times n is just going to be mn. Then I'm going to go m times the 2, which is 2m, so plus 2m, plus, now I come to the 5 times the n is 5n, and then plus 5 times 2 is 10. Check if there's any like terms that I can collect. There isn't, therefore that is in simplest form. Let's have a go at b. If I have x plus 7 by x minus 4, I start off with this term. X times x is x squared. Then x times the negative 4 term is negative 4x. Then 7 times x is plus 7x. And 7 times negative 4 is going to be negative 28. Again, you may want to pause the video there and work through the questions which I've listed on sector, which relate to those binomial product questions. And the last example that I'm going to go through in this video, I have x to the power of 5 minus x squared times x to the power of 3 plus 4. Again, I can see that I've got these x's. these terms with the same bases. So again, I'm going to be using an index law to assist here. So I'm just going to rewrite this question. X to the power of 5 minus x squared times x to the power of 3 plus 4. So I start with this term. I'm going to multiply it by each of those terms, and then I'll move on to this term and multiply it by each. That's how we do these binomial products. So x to the power of 5 times x to the power of 3. They have the same base, and we're going to add the indices. So we have x to the power of 8. Then I'm going to do x to the power of 5 times the 4, which is going to be plus 4x to the power of 5. Okay, then I move to this term here. Remember, because this is a minus, each of these, we need to remember to account for that minus. So I've got minus x squared times x to the power of 3, which is going to be minus x. So that minus comes from this minus here. And now we're going to add the indices, which is going to be x to the power of 5. And then finally, minus x squared times 4 is going to be minus 4x squared. And the final step is collecting like terms. These are of the same order. They're both x to the power of 5. Therefore, I can simplify. 4x to the power of 5 minus an x to the power of 5 is going to be 3x to the power of 5. Then, in fact, let me just do that again. Let's leave the highest order first. So it's going to be x to the power of 8. Then we can do what I just said. So 4x to the power of 5 minus x to the power of 5 is 3x to the power of 5. And then finally, minus 4x squared. So the reason why I stopped doing what I was doing here is because you can see that that was to the power of 5. We like to have our terms in terms of their order. So this was the highest order, being to the power of 8, and then we moved to the power of 5 and then squared. So hopefully those examples will help you work through the questions that I've listed over sector. You're going to be using those for our next couple lessons. So please shout out if there's any of the questions that I can give you a hand with.